So we're starting today about the discussion about the future of roaming with all the aspects relating to modern technologies that have come across, and I'll start now. So we're starting with the year 1992 and things that happened in 1992. Linford Christie wins the Olympic 100-meter gold medal. IBM creates the ThinkPad 700C, which really brings us to home working and working late at night. And Wayne's World, whether you like it or not, I think many of us watched it if you're around in 1992. Windows 3.1's blue screen of death. That's what it reminds me of. And The Age of Intelligent Machines is published, which is really sort of the beginning of AI and everything we know about AI. I think today we don't really find a sentence that doesn't finish with. And really the point of this conversation today is the fact that the first roaming agreement was signed in 1992 and was signed by Telecom Finland and Vodafone UK. Really meant that for the first time people could travel with their mobile phones and travel to another country and still use it. Really the first part of sort of the modern global communications world. So we're starting with sort of the Apple announcement. What happened recently? Apple announces the iPhone 14, an eSIM only environment, no SIM tray. The only way to get connectivity and download a SIM is via an eSIM profile. You have to, most of you already know this, you download a QR code. I think what we're seeing today in the United States is AT&T and T-Mobile have offered this service, and I think that most of the operators around the world are going to follow suit. And what does this really mean for consumers? So we're an eSIM only environment where you have to apply a local profile to users. Now, applying a local profile means that you now take your phone and travel to another part of the world, and you could easily just download a profile, probably at the airport or maybe online, before you arrive to your new country where you're traveling to, and suddenly you're able to download a local SIM. And really what it's going to mean, it's a much better service. It's usually, you'd get a better service. It's significantly cheaper. And I guess we'll all be using local profiles when we travel. So really, this announcement has really pushed the industry forward. It's forcing both the mobile operators, it's opening up a new market in the local SIM profiles, and it's really giving us a lot more flexibility. When roaming is sometimes fluctuates between sort of good prices and more expensive prices, and things change and suddenly Brexit happens and roaming agreements are becoming different, we all see that, you know, local profile is a much better solution for the consumers. Moving on, what does this really mean for the future of consumer roaming? And really it means one or two things, really. Roaming prices will significantly decrease. So meaning that the operators around the world will understand that really they'll have to reduce their prices because they'll find themselves being non-competitive, not competitive. Or roaming will fade out, and it'll be a point where, because we'll all be using local profiles, like downloading a book on Audible or downloading a film on Netflix, there's no real reason why we won't be able to switch significantly to a new profile where we land. And I guess that means that there is a potential where roaming will become a thing of the past. For IoT, though, this is a much bigger problem. For IoT, we understand that, you know, roaming agreements were really built on the consumer ones. They're based on consumer roaming agreements, which were signed between carriers for travelers traveling for usually a short period of time. And really, when we see that consumer roaming will fade out, if we anticipate that consumer roaming will fade out, will there be a sufficient volume to maintain IoT roaming only? And that's a question that we're contemplating today. It's part of this webinar. This is what we're going to be looking at today. And let's talk about why roaming is inadequate for IoT. Firstly, there's high connectivity costs. Typically, we're all seeing that when we're using roaming for IoT, we're looking at long-term contracts, and connectivity costs really are, as we said, they're based many times on consumer roaming agreements. And we know that the operators renew these agreements between 12 to 18 months. And we've got some examples where, you know, many of you had come across this, I'm sure, where you have a fleet of devices and suddenly you get a notification that the roaming agreement has changed because of one thing or another between the carriers. And it's now 5 times the price or twice the price. And long term, this really isn't a solution that the IoT industry can rely upon, especially if we're looking at really large infrastructure and utilities or the car industry, where the agreements are needed. You know, many of the enterprise agreements are 5 to 10 year agreements that the device needs to live forward with. Poor performance. Typically in roaming, we understand that the device sends the data back to its original home network. So the data transverses pretty much around the globe, and we get two side effects on that. The ping time latency is very high, but also there's a lot of points of failure around the network. It's hitting lots of pops around the internet, pops around the world. And there's typically lots of points of failure where the data can lose packets, or there's points where internet data routers may be down, and that will bring your devices down. GDPR violation. Well, this is a point where it's an ever-growing environment that we're living within. Privacy is becoming a very important issue to all of us, but we're also finding ourselves in a point where we don't really understand which GDPR rules in which specific sectors are we violating in a specific country. So it could be that, for example, you have point of sale devices that are in Germany, but the rules for financial services in Germany are different from the ones, for example, in the United States. And if you have a SIM card that's for a US SIM card in Germany in a point of sale device, you might find yourself violating local GDPR rules by extracting the data and sending it around the world, even though it loops back into the host country. So we're finding that GDPR is becoming an increasing problem for the enterprise customers. They're trying to understand, you know, there's suddenly a GDPR person trying to understand the ins and outs of a specific sector and in a specific country. And that's becoming a problem within its own right. Permanent roaming, well, this was again, a two-pronged problem here. The permanent roaming is, on one side, the infrastructure in every mobile operator was not really built for large numbers of permanent roaming or roaming devices. It was built for a small amount, you know, a handful of percentages of the entire network for travelers who are coming off an airplane and they've got a week or 2 weeks or 3 weeks, but it's not built for long term. So the infrastructure on one hand was not built for it. On the other hand, the commercial agreements really were not built on it. Most of the roaming agreements were built on something that the carriers called sort of mutual forgiveness. They, you know, I'll have travelers coming to you and you have travelers coming to my network, and somehow we'll, you know, reconcile at the end of the year. Suddenly, when we put into the equation devices that are roaming permanently, it changes the infrastructure, it changes the network, it changes the performance and how the network needs to prepare itself for the future. So this is a larger problem, both an infrastructure problem as well as a commercial issue. And that's definitely not adequate for IoT long-term, millions of devices roaming permanently on someone else's network. And security enforcement. Well, again, as I said, as long as you're roaming, data is pinging all around the world, and you really have no control of who's seeing it, which data pops around the world are vulnerable. And as a carrier, as an MNO, if you're offering a service to a customer of yours in another country, you really have very little control or very little policy over how the host network is treating that SIM card. And that customer of yours, whether it's vulnerable, and you can't really give them any assurances about that. So from a security point of view, again, we're coming back to infrastructure. Global infrastructure, which you can't control, and the host infrastructure on the host network, which you can't control either. So moving on from there, we're looking at the methods of obtaining local connectivity today. What's happening today? How is it working up until today? So two simple methods that we've all been accustomed to, the enterprise customers of ours: multiple local SIM cards. You're getting a lot of different SIM cards from different, whether it's eSIMs or whether it's plastic SIMs, or it doesn't really matter. Getting different SIM cards from different carriers and putting them into your devices. Or roaming SIM cards, where you take, typically, we all are aware of one global SIM, one roaming SIM covering the whole world and lots of different countries. These are the two methods that we're aware of today. Let's look at the first one. So methods for obtaining global IoT connectivity in terms of multiple local SIMs. What you're challenged with here, and before I go into the details, is really a headache of integration. And perhaps I'll start with an example and then maybe dive deeper in some of the points. So when we're looking at, I'll give an example of a customer e-scooter company that we were working with some time ago, and they had, for example, they had 10,000 e-scooters that were targeted for the United States. And so targeting that market, the local partner was sending them 10,000 SIMs. They approached a local carrier, did their own agreement, and they sent 10,000 SIMs to the factory in China. That factory in China installed them, made sure that they're waterproof, put them inside, and then sent them back to the sent the devices to, or the scooters to the United States. So you can imagine the complexity of this, doing this for every market, in every country, the logistical nightmare, not to mention the carbon footprint about flying plastic all around the world. And we all understand that that's really a possibility that we can do without them for the future. But I'll go into the specific points about this. So I've touched on the integration overhead, multiple different integration, really not something that we could live with. But the poor reliability, really, the coverage gaps. What do? You can't really expect a global manufacturer to start getting SIM from each and every country in the world. So you've got these coverage gaps, which you eventually need to fill somewhere, and you're probably going to use one of these SIMs on roaming. And obviously we're looking at this reliability as well, because at this stage, you don't really have any control of those SIM cards, and you probably have an interface to manage them from the carrier. But if you're managing 20 countries, you've got 20 of these interfaces. That's where we talk about different capabilities, different attributes, the actions, the states, what plans they're on. And those plans might be 12 months, 18 months, and you might find yourself trying to renew these plans down the line. Obviously, a billing and financial nightmare of invoicing so many different carriers in so many different countries, and managing these different, because every single bill will look different. It'll be very difficult to find two plans from different countries in the world that are the same. It could be a time difference, it could be a number of data, megabytes or gigabytes that you've got on that package. And we're looking at operator lock-in. We've got a specific SIM in a specific device, so a specific carrier, sorry, in a specific device. And if you wanted to change them down the line, if your device has a long lifeline and that plan is no longer there, it's very difficult. As we said in the point here, it's very difficult to replace 10,000 devices. It's next to impossible, let's call it. The logistical complexity, which I've spoken about here. So during the manufacturing stage, the inventory management, the multiple SKUs during manufacturing, it adds a level of, or a layer of complexity, which is already complicated, never mind the commercial aspect of it, because if suddenly you've got a big order that you need to fulfill to another country, you can't suddenly take this stock and move it to another country because you've got it destined for a specific carrier in a specific country. Poor service and support, as I actually initially started with that point. the consumer-focused customer service reps really are looking at customers. When you call them up and say, I've got a problem, typically a carrier will say to you, well, what device is it on? You'll say, oh, it's in an e-scooter that my partner makes in another country. They'll probably say that they don't support that device and it's not something that they tested. So very difficult to kind of, if you ever picked up the phone and called and said, I've got a problem with a device, chances are it's not going to be, the network's not going to really think, and quite rightly so. They haven't really tested each and every IoT device in the market, and they will need to look at that. So different time zones and trying to work days, every market's a bit different, but the consumer at the end of the day, going back to the e-scooter, doesn't really care, it just wants it to work. Let's go to the next slide here when we're talking about the second method of obtaining a roaming SIM, which is probably becoming a lot more popular than just getting individual SIM cards, although a lot of customers still use that method. So here we're challenged with what I was touching on 2 slides ago, permanent roaming. Big issue that we are seeing, we're understanding that it's, again, everything I'm actually saying, we understand the problem. We understand that the carriers cannot manage it. It's a problem for the carriers as well. It's not that the carriers are being difficult, it's just that it's an issue. And poor service and support, again, local MNOs trying to deal with consumer-focused customer services. Again, a point that I was touching on before. The GDPR issues, again, every single sector has different methods. I was touching on, for example, the issue of the e-scooters. Every country has different regulations with regards to this. So there is, even in e-scooters, you need to register your name, a driver's license. You're already taking personal information. And do you start moving that data around the world? Chances are you're probably violating a lot of privacy regulations right there. Roaming, well, the offline nature of roaming. So typically 15-minute delayed tap files, billing that is really not real time. Very difficult to decide to shut off a customer at a specific amount of data that they use because of the offline nature. Again, we're talking about operator lock-in. Well, here the example is try ever replacing 100,000 SIMs. Well, another impossible mission, not next to impossible, an impossible mission. We'll give an example here of a customer of ours from some time ago that had tens of thousands of solar panels and was required, after it was shut down during a permanent roaming dispute, to go and replace tens of thousands of solar panels. Now, this isn't something that's in a point of sale in a shop when you can tell somebody to go and replace it. It's on a roof, it's spread out over a whole country. You can imagine the complexity and the nightmare. You know, it can ruin a project completely. And subpar performance, I'll touch on this point again, the throughput, the latency. You know, the operators give a priority to voice customers. And if there's a lot of traffic in a specific area, cells are congested, you'll find that the roaming devices and the data is secondary to the voice calls. So chances are you're going to get lower throughput, latency, because those packets are pinging around the world. And when we're looking at low ping times, and I'll touch on battery operated devices, which are even more susceptible to ping time. The battery operated devices, I'll give an example here. So a 6 months battery life of one of our customers will, between 400 milliseconds and 50 milliseconds is 4 months of that 6 months. So they'll only last 2 months if he's got 400 milliseconds, but it'll last 6 months if they've got 50 milliseconds. So again, in the IoT world, something that we weren't challenged before. And low power wide area network, so narrowband and Cat-M1, less likely to be part of roaming agreements between carriers. So these are the 2 methods that we were familiar with till today, and the various aspects which challenge the IoT sector for connectivity. I always want to, before I move on, I always want to to always remind ourselves in the communications community, in the mobile community, that the enterprise customer is not an expert in this world. He really built a product and he's trying to find a solution which seemingly seems simple for them. And we find ourselves talking to the enterprise customers and understanding that they realize this is a bigger problem than what they anticipated. And I think as an industry, as a sector, we need to solve this and not a burden on them, because it's just becoming more and more complicated for these IoT devices to gain global connectivity. So what is the right solution for IoT coverage? There's these 5 points where we understand that we need to provide in order to build a global IoT coverage for an enterprise customer. Coverage, it needs to be everywhere. It needs to be low cost, or at least at a cost where it's viable for the IoT industry. Obviously, the ARPUs on IoT devices are a lot lower, but it needs to be cost effective enough for IoT devices to operate. It needs to be simplistic enough to operate on a global scale. So we'd expect a single point of management for the entire fleet of devices around the world. The performance needs to be there, probably even more than we expect it to be there for consumers. Perhaps as a consumer, you can feel that if you're landed somewhere and there's no internet for an hour or two, or you're getting subpar performance, you know, maybe your page isn't loading fast enough on your news. But you know, for IoT devices that are not as sophisticated, being in the field, it's a lot more need for high performance. That it needs to be robust. And from a security point of view, again, going back to IoT devices, they need to be a lot more secure because they don't have the CPU power that we have on the modern mobile phones in order to protect themselves. So a device is also vulnerable a lot more. And, you know, for example, if we're talking about utilities or cars, we could only imagine what could happen if utilities get hacked through communications, a simple communications device. So we're looking at network security here, not just device security. The network needs to protect that device as well. So just as we're talking about all of this, really, what are we looking at? What do we need? We need transparency and control. As we were saying, just like we wouldn't expect to, on one of our cloud services, to deploy an application without controlling the compute power, the memory, what security we're using, firewalls, etc. The enterprise customers will not agree to a solution that doesn't control the network, the billing, and provide real-time billing. So touching on all of that, we understand what we need going forward. The old world and the new world. And what was acceptable till now, or what was complicated till now, is going to change. It's changing slowly, but it's happening. And it's happening because the eSIM revolution is upon us now, and it's finally pushed us forward a bit. So we're looking at the new era of IoT connectivity. Where does it mean? What is it going to look like? What's the landscape? What's the infrastructure? And I'm going to touch on a number of points here. So local points of presence integrated with local MNOs, a sort of a super network that's connected between all its points of presence, globally distributed, integrated with local MNOs, sometimes ideally with all the MNOs in a country. And this would basically provide identical behavior. So if you're an enterprise customer, as you're using a single interface, a single infrastructure as well that's connected between all these points of presence, you're getting identical behavior of all your devices. And all of this is centrally billed. So there's one single bill that is provided to you across all your estate. A network like this is geared for performance. So because you've got local points of presence, local IPs, local IP addresses, and you're using local internet, you're not routing data around the world. So the security is there. the security policy which you can deploy at each point of presence is up to you to control. So the enterprise customer can decide that that data has a specific security policy in each country or across all its networks. So they can decide on certain policies, certain ports to be shut down, or allow certain VPNs to send back to their data to be sent back to their ERP platforms, or perhaps even distribute data in the same data center. Again, highly secure. I've touched on all of this now because you control the policy, and it's consumed as a cloud service. We're all familiar with modern cloud services. There's no reason why we really can't provide this today in the mobile space for the IoT sector. So really a full control over billing, network, security, all in real time. And all this is provided via REST API. So the API, because we all understand that the enterprise customers, especially these large enterprise customers who need global connectivity, have their own platforms, have their own management tools, have their own ERP platforms, and they would need certain control through API. Moving on from here, really we're looking at the opportunity for mobile operators. What does this really mean for the mobile operators? Where is it going? And is there an opportunity there? So really what we're saying here is that a legacy MNO will either witness a declining of roaming business because of the advancement or the introduction of an eSIM profile, or are you going to be a modern digitally aware MNO that really monetizes local connectivity? And here, perhaps just being, instead of just using the slogans here, really what we're saying is that an MNO either is going to lose the business because their consumers and IoT devices will use local networks, or are MNOs going to provide local profiles or find a commercial way to provide local profiles even in other countries? How do we enter the new connectivity era? What should you do? Make your profile digitally available. Again, this is what we were saying, I was just saying before. Can the MNOs provide profiles which perhaps are not theirs from a different carrier, but as part of the service? The stickiness is still there. The consumer usually lives in one country, has a residence in one country, has a billing relationship with the carrier where he lives, and would like to continue that relationship. But if he's forced to, he'll probably get a different profile when he's traveling. So can the MNO provide this as part of their offering for travelers? And the second part is, what should you do? Offer as many local networks as part of your solution and not via roaming. And really, we're providing application developers some control, visibility, management, billing layers as necessary, opening up the network. We're very used to the networks being closed in terms of data. Whatever is offered is usually quite minimal. I think what we're expecting from cloud-based services, from cloud-based programming servers, we probably expect from the MNOs, from the infrastructure themselves. So the developers and enterprise developers will be looking for as many layers of data management and control in API form. So they'll be able to enhance their applications, provide a better consumer experience for their services. How should you do it? Well, build your own IoT offering on a modern connectivity management platform that provides both the eUICC and machine-to-machine eUICC technologies on a multi-IMSI technology. So we can flip between IMSIs on different profiles within one profile as well, to provide that greater flexibility. This again for IoT devices specifically. And obtain as many local connections as possible, many locations with a single unified access in one single connectivity management platform. and provide this connectivity profiles as if they were your own across the world. This is really, again, touching on what I've already mentioned, managing and support for global enterprises. MNOs have enterprise customers which are theirs, they've been their customers for many years, but now they need global solutions. And the global solutions that we're giving them today via roaming is just not good enough. And we're seeing this in a lot of the RFPs in the market. They're becoming a lot more sophisticated. The enterprise, the global enterprise customers have demands. They need low latency, they need local profiles, they need to be able to switch. They want to manage everything from a single pane of glass. So all of this is part of what we are going to be doing in the future and what the opportunities are for the MNOs to build upon commercially in the future. I think coming up to the summary here is really Tim Cook paved the way in his announcement for localized global connectivity for both consumers and IoT. It's pushed us one step further by not giving us the option to stay behind here with that SIM tray. I guess we'll leave some time for questions and answers here, and Asaf will be joining me on filtering some of the questions and answering them. So Asaf, I see that our questions are coming through, quite a bit of questions from the audience. Perhaps you can start answering them.
Yeah, thanks. Indeed, we have quite a few questions. We'll try to answer most of them right now, and the rest we will answer offline and send questions and answers to the forum. So yeah, thank you, Rony. So yeah, as I said, we will share the presentation deck, the recording of this webinar, and the Q&A with all the registrants and participants in this webinar. First question, is this your roaming platform for enterprise? So yes, we are talking about FlowLive platform. FlowLive is built in our own hyper-local network that comprises local core networks, and it's already integrated with over a dozen MNOs, and we will have additional MNOs being integrated within the next, I'd say, 3 to 6 months. Next question is, how about the system integration aspects? So the method that we follow is what we call the network-based integration with the local MNOs. In this method, it is FlowLive's core network that is deployed locally in country and integrated with the local MNO. And the fact that we're using all these core networks that look and behave exactly the same, and they're essentially controlled and managed, allows our customers to benefit from many advantages when comparing with the traditional integration methods. To name some of these advantages, so the first one is really seamless localized connectivity that is permanent roaming safe, because we're not relying solely on roaming, but in key countries, we are using the local profiles. The second big advantage is high throughput and low latency. Low latency is today becoming more and more critical for battery-powered devices. As the lower the latency is, it increases the battery life and the lifespan of the device. Another advantage is real-time billing and rating, and this allows customer better cost control, fraud detection, and security enforcement. Another, I would say, last benefit for now would be the ability for us to provide full visibility into the network in every country. So in essence, if you are a customer of ours using the platform, all the devices anywhere in the world look exactly the same, behave exactly the same, and our ability to provide these deep network insights allows for much better self-care and quick fault resolution. Next question, do you think there are any mobile operators who are currently doing a good job of localizing global connectivity? So I can say that to the best of our knowledge, MNOs are not yet localizing connectivity. We know that very few of the global tier ones have deployed the local breakouts in different countries outside of their footprint. This was mainly to improve performance, throughput, and latency, but these solutions are still based on roaming. Some of the MNOs, or all the MNOs using our platform, actually gain immediate access to the rich connectivity library that we provide, and this allows them to seamlessly localize connectivity if and where the need arises. How many networks you are connected to? So I already answered this one. We're currently integrated with over a dozen. Some of these MNOs were integrated with our regional or group MNOs, and they provide coverage in more than one country. And we are constantly adding more and more countries and MNOs as we go along. Next question, what should the GSMA do to address roaming? Very interesting question. I guess the GSMA actually indirectly addressed this issue when they came up with the eUICC standard. Because in essence, the eUICC standard allows you to download the local profile, whether it's M2M or consumer. However, I think that the next step should be, and it will be left for the industry to solve commercially. So the eUICC is one of many standards or many technologies that allows localizing connectivity, but it's now a matter of commercial agreements and so on, and this should be solved within the industry. What else? In what time frame do you expect the decrease of roaming for consumer? Not being a profit, that's a good question. We know that Apple has just recently kicked off this change, and they did this in the US only. We believe that this, Apple will expand this into more geographies with new releases, after the iPhone 14. But it's also very likely that, other handset makers such as Samsung, LG, and others will follow the change. And because hardware is involved and they have to change the handsets themselves, it will probably take a few years. But this is, I think, what we can say about foreseeing the future. The kickoff has just occurred, and others will follow it. How do you work with SIM management platforms? So FlowLive, we have our own self-developed SIM management. We provide all the capabilities and functionality required for hosting multiple profiles on a single SIM, adding a replacement over the air, and so on. We're also integrated with an RSP platform, the eUICC platform. This is provided by Keegan. Keegan is one of our partners, and we are actually today able to combine multi-IMSI or multi-profiles with eUICC to provide a more robust, more flexible solution to our customers. Next question, does this work only with the public internet, or would it also work with the private APN? I can say that the majority of our customers, definitely the MNOs, have their own APNs, and this is not an issue. We are applying private APNs and dedicated VPNs if needed to our customers. Are you already integrated with some operators, and what is the success rate of the profile swap? So yeah, as I answered before, we're integrated with over a dozen MNOs today. Profile swapping, from our experience and records, the success rates are very high today, especially when it comes to multi-IMSI or swapping IMSIs over the reason is that the IMSI itself, the payload is a lot or significantly smaller than an eUICC profile. Therefore, when downloading profiles over the air, downloading an IMSI has, better success rates. We know, and from our experience, that there are areas or use cases where a SIM loses coverage. For this, we provide the ability to preload a SIM with multiple profiles or multiple IMSIs, and the SIM applet can actually make a decision in the field based on predefined rules that if one network fails, the SIM itself can swap to another profile, another IMSI, and try to connect to another network. In this case, you don't need to download an IMSI over the air at all. So I hope this addressed the question. MNOs provide eSIM data plans to offer flexible and seamless connectivity capabilities wherever you are in the world. This is exactly the essence of Rony's presentation. We believe that this is exactly what the MNOs should be doing and will have to do in order to play the new game of global connectivity. MNOs will have to provide their customers the ability to localize or to download local profiles anywhere in the world they operate or they travel. Another question here, how would eUICC support the inherent function in roaming of having multiple networks in each location? I would separate, and I would say the following. eUICC is one of several technologies that enable multiple profiles on a single SIM, similar to multi-IMSI or multiple SIM profiles and so on. Today, we at FlowLive were able to offer our customers local connectivity based either on an IMSI or even on an eUICC profile if this is required. So I think this needs a separation between the technology, eUICC as a technology, and the ability to localize profiles with local networks and so on. How to switch to another provider if the current one doesn't have coverage? I addressed this earlier on. For these scenarios, we have the ability to pre-configure the SIM to swap automatically, what we call the autonomous switching. And therefore, even if the SIM loses coverage, it will be able to regain coverage with another MNO based on another IMSI. Next question, do you expect a different future of roaming for different areas of the world? For example, projects in Europe. Well, it's hard to, specifically for Europe, Europe is currently treated as a single region and connectivity rates are regulated. So perhaps in Europe, roaming will probably last longer than it will in other parts of the world, but it's really hard to predict it at this point. So I'd like to thank you. There are still additional questions. We will adjust them and send them back to you in writing. Thank you very much for participating. Thank you for the good questions. I hope I was able to answer at least the majority of them. Thanks again. Goodbye.
Thank you, everyone, for joining us today, and please get in touch with us if you wish in our various regions. And thanks for the great participation. Hopefully, the team that you are supporting wins tonight. Have a great afternoon and a good morning where you are.